do my best judgment.
Okay.
I'll give you. I'm gonna
Good.
come in right now.
I trust your judgment. So
I'll give it like 20 minutes.
that's true. Oh yeah, I'm videoing it. You can watch it at in your leisure time.
Oh, then I'm
Perfect.
going right now. I'll make sure I give you the person.
Okay.
You start the video again?
I did. Thank you. All right. So we are going to talk briefly about the difference between a relative or local extrema and an absolute extrema. So we're going to start with your white sheet that you should have gotten as you came in. Okay, here's the difference. Remember that a relative extrema, you have to have F prime change sign. Versus also remember this could be called a local, okay, or a relative extrema. An absolute is the same as a global. Now, if you don't know what extrema means, I'm not sure if I used that yesterday. That refers to both mins and maxes. So it's kind of like a generic plural. For if you're looking for mins or maxes, you would just say extrema to include both. Okay?
Like the extremes of both sides.
Yes, you got it. So look at the first graph. Does the slope ever change from negative to positive for a relative minimum? Does my slope ever change from negative to positive on that graph? Yes, where does that happen? Right here at this point. So the relative minimum is always a y value. So at this point, how low does it go? 0, it occurs at also x equals 0. So this is always a y value. It occurs at an x value. Now, is that the lowest point overall? No. Where is the lowest point overall? We're going to just cut the graph off. Pretend like it doesn't have an arrow. -4, and it occurs at, we'll say -5 is probably more like maybe -6, but we'll just round it. Okay? So notice that my absolute max occurred here. I said that wrong. Absolute min occurs here on the side versus my relative min occurred in the middle. Okay, now let's do it for maxes. Where is my relative max? Okay, very good, at the cusp. Now, how high is it at that point? 1, and it occurs at -1. Is that my absolute max? Where's my absolute max? 4, it occurs at x equals 2. So notice that in this case, both my absolute min and my absolute max occurred at endpoints. They did not occur at the lowest or the highest, the little relatives. Okay? Come down to the next graph. Do I have a relative low point or a relative minimum on the next graph? Okay, where? So relative, there has to be a sign change. There has to be a dip. So it would be 4, 1. The relative min is 1. It occurs at 4. But the absolute minimum occurs where? At 0. It occurs at 0. Relative max. Do I have a place where the graph switches from a positive slope to a negative slope? 2, 3. But what's wrong with 2, 3? It's open, so you would say none. If I had a point at 2, 3, I would use that. But since it's open, that does not count. Okay, now, do I have an absolute max? Yes, it is 5. It occurs at 5. That one is supposed to be closed, yeah. I just drew these graphs, so that's why they kind of suck. Thanks. Okay, next one. Look at it. Where is my relative minimum? The sign has to change from a downhill slope to an uphill slope. None. Very good. Now, does that mean that there's not a minimum value? No, it just means there's not a local minimum. Okay, where is my absolute minimum? -1. Where does it occur at? -1. Would I also include 5? Because it's open. Very good. If it did have a closed circle, you can list that it happens more than once. Okay, let me give you an example of that. Let's say on your CBA, a couple of people got hundreds, right? Are there multiple maxes? No. What was the max grade? 100. Did multiple people get it? Yes. But was there still a max grade? Yes. Does that make sense? So you're looking at the Y value. Only one Y can be the biggest, or the smallest, or whatever. Okay, relative max. Where does it happen? It is 2. It occurs at 3. Last one, absolute max is, it occurs at 3. So your absolute and relative can happen at the same point. This is the relative and the absolute max. So they could be different, but they also could occur at the same point. Okay, last graph. We're going to let this one have an asymptote, so put little arrows on the end. Now, what type of asymptote is that called? You should have learned about those in pre-cal. A slant asymptote. Good job. Wow, I was not expecting anybody to know that. Okay, so a slant asymptote means you still get closer and closer to that line, but you're getting closer and closer to a slanted line, yeah? Okay, so do I have a relative minimum where the slope of the graph changes from a negative slope to a positive slope? Where does it happen? At 0, 0. Because see, look, what happens on the left? I have a negative slope, then I have a positive slope, so that counts as a relative minimum. Now, is it the absolute lowest point on the graph? No, because how low do these arrows go down? For forever, so you'd say none. Okay? No. Usually you would just say there's not an absolute minimum. Okay, my relative maximum. Do I have a place where the slope changes from uphill to downhill? Where? Comma. Good. So it is -8. It occurs at -2. But kind of same story here. On the other half of the graph, it goes higher forever and ever and ever, so you would say there is none. Got it? Questions about that or good so far? Sure. Okay, so now we're going to transition back into your normal notes. Okay, so we're going to write the steps first, and then we'll do probably 4, maybe 5 examples, and then work on homework. Okay? Everybody good on this white sheet? Okay. Step number 1. You are going to find f prime of x. Okay, that should sound familiar. That's also the first step of the first derivative test. Okay, step number 2. You're going to find your critical numbers. Do you remember how to find those? Good, perfect. So at first you're thinking, are you tricking me? This is the same. Okay, yeah, so far it is. Step number 3, guess what you're going to do? Yep, an interval test on the number line. Okay, and then what do we use the interval test for? To find relative max and mins. Find relative or local max and mins. Now, just because they're the relative max on their own little area, or the relative min on their own little area, does that also make them the biggest overall? No. Yes? Yes. So steps 5 and 6 are where it's different. So everything up there was the same. Step number 5, you're going to make a candidates table. And your candidates table is going to include your critical numbers and your endpoints. Okay? And then in step 6, you're going to identify your absolute or your global max and mins. So really, a lot of it is kind of the same as what we did yesterday. You just have 2 new steps added to the end. Okay? So, first example we're going to do is going to be kind of easy. Okay, so we're going to find, number 1, absolute extrema. Remember, that means mins and maxes. That includes both. For f of x equals x cubed minus 3x squared on the interval from -2 to 3. Okay, steps 1 through 4 are the same, so we should already be able to do those. We take the what? Derivative, set it equal to 0. Find your critical numbers. Do your number line test. All of that's the same. Okay, so go ahead and do that first. So f prime equals what? Minus. Okay, set it equal to 0. What can I take out? What's left over? What are my critical numbers? 0 and 2.
Why is it 0 then?
So anytime that you GCF an x out to the front, that's going to give you 0 as a solution. Now, quick point here. What if I had only GCF'd out a number like 3? You would not include 0. Okay? All right, number line test. F prime on the bottom, F on top. Remember, that's what we learned about yesterday, is the relationship between those. Okay, 0 and 2 go on my number line. I am not going to write down the sign analysis. We're just going to do it out loud. So let's say I pick 3. I'm plugging in right here. What's 3 times 3? Positive or negative? What's 3 minus 2? Multiply 2 positives. Positive overall. Next, I'm going to plug in 1. 3 times 1 is? 1 minus 2 is? Multiply positive and negative, you get a negative. Smaller than 0, say I pick -2. 3 times -2 is? And -2 minus 2 more is also. Multiply 2 negatives, you get a positive. Good? If f prime is positive, what was f doing? Increasing. When f prime is negative, f was decreasing. And then when f prime was positive, f was increasing. So who are my relative winners? I have a relative max at 0. I have a relative min at 2. But here's the question. There are 2 ways that your graph could look. Okay, let's say it goes like that. If my interval, I'm going to just use my hands here. If my interval is here, pretend, okay, then would my max be the highest that I already found? And would my min be the lowest? Okay, what if I move my fingers out to here? Is my max still the highest? Where's the highest? On the end point, yeah? What about my min? It's not the lowest anymore either, because this side goes lower. So that's the question that you're answering when you do a candidate's chart, is does my end point beat my local min or max? So set up a table for me, just like a normal little chart. And 0 and 2 are going to go in it, as well as -2 and 3. So -2 and 3 are my end points, and 0 and 2 are my critical numbers. Okay, those are what go in your chart. When you plug in, you want to know whose y value is the biggest. So you're going to plug into the original equation. Okay, I'm going to put that right here. This is f and f of x. You're going to use the original, not the derivative, equation, which is right here. So let's plug in -2 first. -2 cubed minus 3 times -2 squared. -2 cubed minus 3 times -2 squared. What is -2 cubed? -8. What is -2 squared just by itself without that? 4. -3 times 4 is Negative 12. What's negative 8 minus 12 more? Negative 20. Okay, next we're plugging in 0. What is 0 cubed minus 3 times 0 squared? 0. Okay, next let's plug in 2. 2 cubed minus 3 times 2 squared. What's 2 cubed? 8. Minus 3 times 2 squared is 3 times 4. So I'm minusing 12 from 8. What would I get? Okay. And then last one is a 3. 3 cubed minus 3 times 3 squared. But if this is 3 squared, that's 9. Times 3 again is 27. So this is really 27 minus 27. What's that? 0. Okay, then looking at your chart, who is the absolute maximum y value? 0. Where does it occur? At 0 and 3. Where's the absolute min? It's negative 20 at negative 2. Make sense? Okay, so absolute max is 0 at x equals 3. Absolute min, oh wait, hold on, 3 and, thank you, 0. And my absolute min is negative 20 at x equals negative 2. Okay, now, I have one more kind of easy example if we need it, but if we're okay to kind of skip it and go to the harder ones, good with that? Okay, we're going to do a trig one, okay, so get excited. Next one is going to be x plus 2 sine x. X plus 2 sine x. And it's going to be on the interval from 0 to pi. Okay, yes. Okay, step 1, take the derivative. What is y prime? 1. Then what about the derivative of 2 sine x? That is a 2 sine x. It's kind of scribbled because I forgot to write the 2. It is a plus, yes ma'am. So the derivative of plus 2 sine x would be plus 2 cosine x. Then I set that equal to 0. So I have 1 plus 2 cosine x equals 0. Okay, they do this pretty frequently on the AP test where you have to solve. So I'm going to minus my 1 across. So now it's negative 1 equals 2 cosine x. And then what could I do after that? So now it's negative a half equals cosine x. So far so good? Okay, on your hand. I want 1 cosine finger. Who am I going to fold? This one. That would be root 2 over 2. We only want 1, so it'd have to be that one. Yeah, cosine's 1 over 2. So it's going to be pi thirds. Okay, but do I want a half? I want negative a half. So now I got to think about my quadrant. So let's draw a little picture here. All students take calculus, and I want negative a half for cosine. What quadrants is cosine negative in? Sine and tangent. Quadrants 2 and 3. Very good. So if this is 3 pi thirds, what would my angle be here? 2 pi thirds. And now here would be 4 pi thirds, but is that on my interval? So I only end up with 1. Okay? Set up your number line here. 0 and pi are my endpoints. 2 pi thirds would be a little bit closer to pi than it would be to 0. Okay, I'm going to plug in my endpoints because they weren't critical numbers. So I'm plugging in, though, to look right here. Okay, so ready? We're going to plug in 0 first. What is the cosine of 0? 1. What's 1 plus 2 times 1? 1 plus 2 is 3, so it's positive. So put a little plus sign. This first interval is positive. Now, I want to pick a number bigger than 2 pi thirds. Well, then I'm going to pick pi. So, ready? What's the cosine of pi? -1, right? Cosine of pi is -1. What's -1 times 2? -2, but then I'm going to add it to 1. Overall, what's the sign? Negative.
Wait, so for this interval, you use 0?
Okay, here, let me explain something real quick. I can use 0 because was it a critical number? No. That's why you can't think about, like, my number line goes back forever and ever and ever. I'm just picking 0 because it's an easy number to plug into cosine. So you can't plug in critical numbers, but 0 is just an endpoint here, so I just used that because it was easy. You could have used, though, pi 6. There's some other angle if you wanted to. Okay? So if f prime is positive, f was increasing, then it was decreasing. What does that make 2 pi thirds? A local what? Max. But it's not automatically the absolute max. We have to do a sign chart. So, candidates test here. What goes in the chart? What are my endpoints?
0.
And 2 pi thirds. 2 pi thirds. I wrote that really weird, but just pretend. Okay, where are we plugging in to? The original. Very good. So, x, f of x. So, this first one for 0 is going to be 0 plus 2 sine 0. What's sine 0? 0. 0 plus 0 is? 0. I'm going to do pi next just because it's easier. Okay? So, pi plus 2 sine pi. What's the sign of pi? You're still on your pinky. Still no fingers on bottom, so it's pi plus 0 is pi. Next one, we're plugging in 2 pi thirds. That'd be 2 pi thirds plus 2 sine 2 pi thirds. Okay, now let's think about pi thirds. That's still this finger, but now I want my sine fingers on bottom. That's root 3 over 2. Now question. So hold on. 2 pi thirds plus root 3 over 2. Okay, question here. If I'm in 2 pi thirds, is sine going to stay positive? Yes. But you have to think about that to make sure. Now, what did I forget to write here? Remember my 2? I'm going to put that right here in a second. Okay, now why is that 2 going to help me out? What's going to happen with the 2 on the bottom? They're going to cancel out. So really, this is just 2 pi thirds plus root 3. Now, let's do a little bit of generalizing here. Pi is about 3. Yeah, it's pretty close to 3. So what's 2 times about 3? 6. 6 divided by 3 is about 2. And then plus root 3. Okay, root 3 is like 1.2 or something. So if I add those together, will that be bigger than 3.14? Yes. If you're not sure, put it in the calculator. Okay, they're not going to give you an estimation on the AP test that's not obviously one's bigger than the other. So this one is going to be barely bigger, which means it'll be my absolute max. What will my absolute min be? 0. So your absolute min is 0 at 0. Your absolute max is 2 pi thirds plus square root 3 at x equals 2 pi thirds. Okay? Alright, 2 more left. Next one is going to be y equals x plus 4 over x. We're going to be looking on the interval from 1 to 5. Can I take the derivative of that as is?
Can't you put 1/4 x?
That's actually not the same.
Oh,
What could you put though instead? If x is on the bottom, it would be x to the minus 1. That's what we're going to do. So rewrite. This is x plus 4x to the minus 1. Are we all good with that? Okay. Take the derivative. What's the derivative of x by itself? 1. Take the negative 1 down. Now what is it? negative 4x to the negative what? Negative 2. But nobody likes it like that, so I'm going to do 1 minus 4 over x squared. So far, so good? Okay, I cannot do a derivative test on it if it's separate pieces. I have to get a common what? Denominator. How will I go about doing that? Multiply by what? Over x squared. Remember, they have to match or you can't combine it into one big fraction. So now I'm going to have x squared minus 4 over x squared. And then to identify my critical numbers, I'm going to need to factor the top. So if it's x squared minus 4, that can split up how? Yep, x plus 2, x minus 2. And then on the bottom, x squared. Now there are 3 critical numbers in this example. What are the 2 on top? What's the one on bottom? 0. So remember, your critical numbers have to come from anything on top and anything that would make the bottom 0 as well. So my critical numbers are plus or minus 2, as y'all said, and then 0. Number line, negative 2, 0, 2. Okay, let's say I pick 3. I want to be over here in the positive side. 3 plus 2 is positive. 3 minus 2 is positive. Times those together, it's a positive. Now, why did I not even look at the bottom? Because it's squared. It has to be positive. So I don't even really care about the bottom. That's always positive. So when I'm checking for my plus or minus, I'm not even going to check that part because it's not going to make a difference. Okay, let's say I pick 1. 1 plus 2 is positive. 1 minus 2 is overall negative. Say I pick negative 1. Negative 1 plus 2 is negative 1 minus 2 is negative. Multiply those together. Negative. Last interval, negative 3. Negative 3 plus 2 is negative 3 minus 2 is multiply 2 negatives, get a positive, which means that it goes up, down, down, up. Does anybody not qualify to go into the chart as a min or max? 0. 0 doesn't count because it doesn't have a what? A sign change. Okay, set up your chart. So I'm going to put 1 and 5 as my endpoints. And then negative 2 and 2 are both going to count. But sad 0 doesn't count because it's not a min, it's not a max, it's a neither. Okay, we are plugging in here. Ready? So it's going to be 1 plus 4 over 1. What's that going to be? 1 plus 4 is 5. Next I'm plugging in negative 2. Negative 2 plus 4 over 2. Negative 2 plus 2 is 0. Next one I'm plugging in is 2. 2 plus 4 over 2.
Wait, wouldn't it be 4 over x? It should be 4 over
Oh, that is a negative 2. Thank you. Oops. Oh, no, I made it worse. Okay, 4 divided by negative 2 would be minus 2. So it'd be negative 2 minus 2 is how many? Thank you. Negative 4. The next one, 2 plus 4 over 2 is 2 plus 2 is 4. Last one is 5. 5 plus 4 over 5. Now, can I leave it like that? Sure. Okay, the point is that if I'm looking for the biggest thing, what's bigger, 5 or 5 and a fourth? That's my absolute max. What would my absolute min be? Negative 4 at 2. Got it? Make sense? Okay, I'm not going to write it out. I'm just going to put a little star max and a little star and then a min. Maybe I'll put ABS on it to remind you. Those are the absolute winners globally. Okay, we have one more kind of harder like that and then we'll work on homework. Okay, last one in your notes. You're done? Okay. Alright, last one. Y equals 2x minus 3 cubic root x squared. And we're going to do it on negative 1, 8. Okay, I want you to rewrite it. I want you to take the derivative, and then I want you to get a common denominator. So do all those things. Would you like a motivation candy while you're doing it? Okay, of course. That is a cubic root of x squared. Okay, so you're rewriting, taking the derivative, and then getting a common denominator as well. All three of those steps.
Oh, it's touching it.
Do you just love animals, or what were you gonna ask?
What power is it?
I'm taking my day. Got one? I didn't know you were in band. And I saw you out there
I
in
was
band
teaching
too.
one of my friends.
You were just like laying on the floor. You like weren't even doing
They call them
anything.
coffin crew because they just lay there.
You do what?
They call them coffin crew because they just lay there like.
Oh, behind the spinny things? The visual pop, if you will. Yes. That's right. You only had to find that. So, okay, I'm going to finish giving you candy after we do a little bit of this. So, what's the derivative? Oh, wait, hold on. Rewrite first. My bad. So, 2x minus 3x to the what? 2/3. Derivative of 2x is 2. Derivative here, 2/3 times 3 is just a 2x to the negative 1/3. Yeah? Okay, but nobody likes it like that, so 2 minus 2 over cubic root x. So far, so good. Looking at that. So the 2 stays off on its own, minus 2 stays on top, cubic root x goes down. We need a common denominator. What are we multiplying the first 2 by? Cube root x, cube root x, which means that now my y prime is this. 2 cubic root x minus 2 over cubic root x. Anything else I can do to it? There's a 2, and there's 2 of them, right? So I'm going to GCF it out. Okay, how many x's do you see in your fraction? 2. That means you're going to have how many critical numbers? 2. What will make the top 0 if x is what? Okay, top, 0 won't work. 1. What's 1 minus 1? 0. Now you're like, oh, there's a cubic root. What's the cubic root of 1? Still 1. Then minus 1 is 0. So x can be 1. What will make the bottom 0? 0. Now, real quick question. When you're doing your homework, okay, do you have to know if there's a sign change at either one of these? Okay, kind of be lazy here for a second. No, not really. What if there's not a sign change? What are you going to do? Just not put it in the table. So, if you don't feel like doing that, that's fine. Okay, just jump to your table and just make sure you include both of them. Whether there's a sign change or not, if you don't really care, then just check both of them in the table and you won't get anything wrong. Okay, so negative 1 and 8, 0 and 1. So I don't feel like it, So I'm going to skip it. But if I'm going to skip it, I have to include everybody that was a local candidate. I can't eliminate anybody unless I check that. Okay? We are plugging into the original, which was 2x minus 3 cubic root x squared. Let's plug in 0 first because it's easiest. What's 2 times 0 minus 3 times 0 squared and cubic rooted? 0 minus 0 is 0. Let's do 1 next. 2 times 1 minus 3 times the cubic root of 1 squared. Okay, well that's really just a 2, right? That's just a 1. So what's 2 minus 3 times 1? Negative 1. Okay, let's do 8. 2 times 8 minus 3 times the cubic root of 8 squared. What's the cubic root of 8? 2 squared is 4. So really this is 16 minus 4, which is, oh wait, hold on, 3 times 4. So that's really a 12. 16 minus 12 is 4 left over. Okay, last one. Do it on your own. Negative 1. And then I want you to fill in the blanks. Absolute max is blank at blank. Absolute min is blank at blank. So it'd be 2 times negative 1 minus 3 times negative 1 cubic rooted and squared. That's a negative 2 here in the front. But what is negative 1 if I cubic root it? Still negative 1, but then I square it. Positive 1. So it's minus 3 times 1. Negative 2 minus 3 more is negative 5. Label your chart. This is x. This is f of x. So where's my absolute max? It is 4. It occurs at 8. What's my absolute min? It occurs at negative 1. Make sense? Okay, those are the only examples that I put into it because I want you to have time to look at the back of your homework. So flip over to the back. We have time for maybe 1 or 2. I want you to do number 13. And then let's do a trig one. Let's do number 15. 13 and 15 off the back. Who do I make it up to VHS here? Yeah. Alright, you're doing, I'm going to finish passing out your candies. You do those 2 on the back, 13 and 15. Work together with each other. You can do it.
You just plug it back into the original.
You do realize that what day is today? Look, y'all, I have Aladdin checks. Are you jealous? Talk about adulting right. Okay. Thank you. And then also, guys, I told the other class, your homework 14 and your quiz need to be turned in tomorrow. But if you need an extra day on this, since we just finished the notes on it, you can turn it in Monday. But your quiz and homework 14 are still due tomorrow. But you can have an extra day and turn that in on Monday. Yes. Yes. The quiz is the only.
Oh, wait, no. I'm sorry, 15.
No, this was practice. So homework 14. If you need an extra day on it, well, this was last. Well, this I'll do. Okay. But the front side of this, I'll do something during lunch today. I don't know anything we're doing right now, to be honest. Okay. You gotta fix that. Would you like motivational candy? Candy? Joelle, are you doing what you're supposed to be doing?
Yeah, I was asking.
Or are you getting a little distracted? Yeah. You can skip it. Oh yeah, and then guys, you can find the Y values in the calculator. It says that in the instructions, but I know some of y'all don't want to really read the instructions. So if you want to find the Y values with a calculator, especially since it's kind of long, that's fine. Candy? Okay, Marisol, you can take the derivative though, right? Marcel, you can take the derivative. Tristan, did you want one?
No, I don't know how to take the derivative.
You don't know how to take a
No, I
derivative.
said I do know how to take it.
And then set it equal to 0. You know how to do
Yeah, I know
that.
how to do that.
Want one?
I don't know.
I'll let you call me this.
Would we use the original or?
When you're plugging in the
Yeah,
original.
which one I
Go to Candy?
did.
Yeah. Yeah, I think it's in there.
I thought it was
But that one, this is
It's actually got 2.
this top.
Okay, now let me show you what I mean by, if you read the instructions, okay, it says to find the critical numbers or whatever by hand, but then it says you may use your calculator to find the Y values. Okay, so this is what I mean by that. Have y'all finished the critical numbers on 13? What are they? 0, negative 2/3. Okay, so I'm going to skip the line test because I already know how to do it and this is my homework and I can skip it if I want to. Okay, what goes in my chart? Now, you should have the derivative equal to 0 and then solving. I'm just skipping that because you had time to do it. So, negative 1 and 1. What else? Negative 2/3 and 0. This is the part that you may use your calculator on, okay? So I'm going to show you how to do that in case you don't know how. Okay, negative 2/3, is that going to be in your table? No, but that's an easy fix. So I already have this one typed in. Remember that you can do this. Okay, alpha trace, y1, and then plug in negative 2/3. Okay? So if you would like to do it that way, if it's a number not in the table, like pi 6th or pi 4th, you hit alpha trace y1, and then you just put the number you want in parentheses. Okay? So alpha trace, what else was I plugging in? 1. And then 0, I already know, if it's 0 plus 0 plus 9, it's going to be 9. So I'm going to write those into my table here. Hopefully you can kind of see both. Negative 2/3, my Y value is 9.7407. At negative 1 it was 9. At 1 it was 19. And then at 0 it'd be 0 plus 0 plus 9, which is 9. And then out of those choices, my absolute max would be which one? 19. Absolute max is 19 at x equals 1, and my absolute min is 9, and it occurs at what? Negative 1 and 0. And remember, your max and mins can happen more than once. That's okay. Okay? Alright, if you need help on the calculator part, raise your hand and I'll help you with that. Okay? Okay, did you take the derivative?
Yeah.
And then you factored out, and oh, that should have been a 3x here. And then that should have been a 10 because 5 times. So you have a couple errors in your derivative. So you have to do the derivative and the setting to equal to 0 by hand. You could, it would just take forever if it's a fraction. So, am I answering your question? Yeah. So type in y equals, so it's already in there, and then hit alpha trace, and then Y1, and then put in parentheses. Just delete. So hit second quit, get out of there. So go hit alpha trace, and then parentheses, the number 16.
Yeah, it was November. November 6th.
I think we changed the equation. Yeah. You don't have to do it. Just the
Probably like
Okay, let's get you caught up. Come on.
I gotta see the
I already gave you the numbers. What time is it on?
11:46.
And you get out of 6 and about as fast.
It literally rings like
Okay.
I'm making sure if I
You can do it. Homework 14 and your take-home quiz. Tutorials after school today if you need to correct your CBA for the curves.
When is the last day we do that?
Next week.
I would just keep checking the classroom because I don't know whenever I do.
Marcel, do you need to stay during lunch today? To get your life together?
honestly, next week, like I was gonna come take money out of school. You don't have
Okay. You do have a lot of missing work. I'm more worried about you missing a lot of stuff we do in class. Do you take notes?
Yeah, I take notes, and it's hard for me to look back at them because my handwriting is really bad.
Yeah.
I do take notes.
Your CBA?
Zero for the CPA.
Oh, and didn't I just give it back to you? Okay, I'll put it on for it, because I did see it. Yes, you can. Go to the black shelf, top left tray, pull out your Scantron and
Yeah, it was just a word. Okay, so y'all didn't do anything on here or anything?
I'm gonna sell it for
There's a
cheap.
129 that you